For centuries, humanity believed the Milky Way was the entire universe. Nothing beyond, no galaxies, no cosmic neighbors. But then one man, Edwin Hubble, looked through a telescope and saw something so shocking, it shattered everything we thought we knew about existence. This single moment didn't just rewrite astronomy, it changed humanity's place in the cosmos forever. Welcome to Starsky Science. If you're fascinated by the mysteries of the universe, make sure to subscribe to our channel. We explore the deepest questions of space, time, and existence itself, bringing you the most fascinating discoveries in astronomy and astrophysics. And today, you're about to hear the story of one discovery that shook the very foundation of science. Let's step back to the early 20th century. At this time, astronomers thought our galaxy, the Milky Way, was the entire cosmos. The faint, cloud-like smudges in the night sky, known as spiral nebulae, were believed to be gas clouds inside our galaxy. They looked mysterious, but no one seriously imagined that they could be other vast star systems much like our own Milky Way. The universe, in the minds of most scientists, was confined to one giant island of stars, and nothing more. But Edwin Hubble was about to prove them wrong. In 1917, the largest telescope in the world had just been completed, the 100-inch Hooker telescope at Mount Wilson Observatory in California. This instrument was a giant leap forward in technology, capable of seeing deeper into the night sky than ever before. And Hubble, a former lawyer turned astronomer, was determined to use it to answer one of the most pressing questions of the age. What are those spiral nebulae? One of those nebulae was Andromeda. To the naked eye, it appeared as a faint, blurry patch of light. For centuries, cultures had noticed it, but no one had truly understood what it was. When Hubble turned the Hooker telescope toward Andromeda, he wasn't just looking at a smudge, he was looking into a cosmic mystery. Then, in 1923, came the breakthrough. Hubble identified a star within Andromeda, known as a Cepheid variable. Cepheids are extraordinary because their brightness pulsates at regular intervals, and that pulsation can be used to calculate their distance. The star Hubble observed was far, far beyond the edge of the Milky Way. In fact, it was nearly 1,000,000 light-years away. This was the moment everything changed. The Andromeda Nebula was not a gas cloud inside our galaxy. It was another galaxy entirely, an island universe of its own, filled with billions of stars. The universe had suddenly expanded in size, not just by a little, but by a staggering amount. The Milky Way was no longer the entirety of existence. It was just one among countless galaxies scattered across the cosmos. Hubble's discovery didn't just open a window. It blew the walls off our understanding of the universe. For the first time in human history, we knew the universe was far bigger, far older, and far more mysterious than anyone had ever dared to imagine. But Hubble didn't stop there. Over the following years, he continued his research, examining the light from galaxies and noticing something extraordinary. When he analyzed their spectra, he saw that the light was shifted toward the red end, redshifted. This redshift indicated that the galaxies were moving away from us. And not just a few galaxies, all of them. In 1929, Edwin Hubble announced his second, even more revolutionary discovery. The universe is expanding. Think about that for a moment. The fabric of space itself is stretching, carrying galaxies apart. This wasn't just shocking, it was paradigm-shifting. It implied that the universe had once been smaller, denser, and hotter. Decades later, this insight would become the foundation of what we now call the Big Bang Theory. At Starsky Science, we explore these moments not as distant historical curiosities, but as living milestones that continue to shape how we think about the cosmos. And if you haven't subscribed yet, now's a good time, because what Hubble revealed is only the beginning of a much bigger story. When you look at the night sky today, and you see countless galaxies in telescope images from Hubble Space Telescope or James Webb, remember that less than 100 years ago, humanity believed the Milky Way was the whole universe. Edwin Hubble's careful observations turned that illusion into knowledge. His work bridged the gap between the old, small universe and the vast, expanding cosmos we now study. And here's the incredible part. His discovery didn't just change astronomy. It changed philosophy, religion, and human self-perception. Suddenly, Earth wasn't even in the center of one great galaxy. It was a tiny speck in a universe teeming with galaxies, each with its own billions of stars and perhaps countless planets. This raised profound questions. If the universe is that vast, could we truly be alone? If galaxies stretch for billions of light years, what does that mean about the future of the cosmos? And how did it all begin? Scientists from NASA and observatories around the world often cite Hubble's work as the starting point for modern cosmology. His observations laid the groundwork for nearly every major discovery since, from the cosmic microwave background radiation to dark energy. Without Hubble, our understanding of the universe would still be trapped inside the Milky Way. And the story of Edwin Hubble is just as fascinating as his discoveries. Born in Missouri in 1889, Hubble wasn't destined from childhood to be an astronomer. In fact, he studied law at Oxford and even practiced briefly before following his true passion, the stars. He combined a disciplined mind with a poetic sense of wonder, often describing the universe not just in numbers, but in beauty. His colleagues remembered him as both rigorous and imaginative, a rare combination that made his insights groundbreaking. By the time of his death in 1953, Hubble had become a legend, recognized as the father of observational cosmology. But the universe he revealed was still full of mysteries, many of which we are only now beginning to understand. When Edwin Hubble published his groundbreaking results in 1929, the world of science was stunned. His paper was short, only a few pages long, yet its implications were massive. He showed that the farther away a galaxy is, the faster it appears to be moving away from us. This relationship became known as Hubble's law, and the constant that describes it, the Hubble constant, remains one of the most important numbers in all of cosmology. To appreciate the shock of this discovery, we need to remember the mindset of scientists in the early 20th century. For centuries, Western astronomy had leaned on the assumption that the universe was static and eternal. Even Albert Einstein, when he developed his general theory of relativity in 1915, believed the universe must be unchanging. His equations actually predicted an expanding or contracting cosmos, but Einstein adjusted them, adding what he called the cosmological constant, to force the math to fit a static universe. Later, when Hubble's discovery of expansion became undeniable, Einstein reportedly called that adjustment the biggest blunder of his life. Imagine being a scientist at that time. The night sky you thought was permanent and fixed was suddenly revealed to be in motion, constantly stretching, evolving, transforming. Hubble's redshift observations showed that galaxies weren't drifting randomly. They were all moving away from us, as if space itself were expanding like the surface of a balloon. This meant the universe had a beginning. It hadn't always existed in its current form. It was born, it grew, and it continued to grow. That idea, revolutionary as it was, sparked heated debates. Not everyone was ready to accept it. Some scientists favored what later became known as the steady-state theory, which suggested that as the universe expanded, new matter was continuously created to keep the overall density the same. This idea preserved the comforting notion of an eternal cosmos, without a beginning. But Hubble's observations kept pointing to something else, something more radical. In the decades that followed, additional evidence began to pile up. Radio astronomers in the 1960s discovered the cosmic microwave background radiation, a faint glow that fills the universe. This radiation is the afterglow of the Big Bang itself, a relic of the moment when the universe first became transparent to light. Suddenly, the expanding universe model wasn't just a theory, it was supported by direct evidence. And it all traced back to Hubble's discovery. At Starsky Science, we love to explore how a single observation can cascade into an entirely new understanding of reality. This is one of those moments. If you haven't subscribed yet, make sure to hit that button so you don't miss our upcoming explorations of space, because every new discovery builds on the foundation Hubble laid. But let's not rush past the details. Let's dive deeper into what Hubble actually saw, and how he convinced the world that galaxies were not only real but moving away from us. Hubble relied on an essential tool, spectroscopy. By analyzing the light from galaxies through a prism, astronomers could spread it into a spectrum, a rainbow of colors. Embedded in that spectrum were absorption lines, fingerprints left by elements like hydrogen, helium, and calcium. In laboratory experiments on Earth, these lines appear at fixed wavelengths. But in the light from distant galaxies, Hubble noticed they were shifted toward the red. This shift wasn't random. The farther away the galaxy, the greater the redshift. That meant velocity and distance were linked. This wasn't just a minor adjustment to astronomy. It was a revelation. It showed that the universe was dynamic, alive with motion, and far from the static backdrop people once imagined. Interestingly, Hubble himself was cautious about interpretation. He reported the data and described the redshift, but he did not immediately declare it as proof of cosmic expansion. It was later scientists like Georges Lemaitre, a Belgian priest and physicist, who boldly connected the dots. Lemaitre proposed that the universe had begun from a primeval atom, what we now call the Big Bang. Hubble's data provided the backbone, but it took the vision of others to frame the universe's origin. This collaboration between observation and theory is what makes science so powerful. One person may open the window, but it often takes a community to describe the entire view. The expansion of the universe also led to new questions. If galaxies are moving away from us, does that mean we're at the center of the cosmos? Not at all. Expansion is happening everywhere, equally. Imagine dots on the surface of an inflating balloon. From the perspective of any one dot, all the others seem to move away. There is no special center in the balloon's surface, just as there is no center in our universe. This realization was humbling. Humanity had already been displaced from the center of the solar system by Copernicus, and from the center of the galaxy by 20th century astronomy. Now even our galaxy was shown to be just one of billions, each drifting apart in an ever-growing cosmic sea. But Hubble's work went beyond just the expansion. He also devised a classification scheme for galaxies, known as the Hubble tuning fork diagram. By studying the shapes of galaxies, he grouped them into categories: ellipticals, spirals, and barred spirals. This classification became a cornerstone of galactic astronomy and is still used today. His careful, systematic approach revealed that galaxies weren't just distant smudges of light. They were structured, organized, and diverse. Over time, Hubble became a symbol of modern astronomy. His name now graces the Hubble Space Telescope, launched in 1990, which has given us breathtaking views of the universe in unprecedented detail. From the pillars of creation in the Eagle Nebula to the Hubble Deep Field showing thousands of galaxies in a tiny patch of sky, the telescope has extended his legacy into the modern era. And here's something fascinating. When the Hubble Space Telescope first launched, it had a flaw. Its main mirror was ground incorrectly, leading to blurry images. The media mocked it, and it seemed like a disaster. But NASA engineers designed corrective optics, installed by astronauts on a daring space shuttle mission in 1993. After that, Hubble became one of the most successful scientific instruments ever built. The irony is beautiful. The telescope named after Edwin Hubble had its own moment of blurred vision, corrected just in time to reveal the universe with stunning clarity. Every great discovery leads to new mysteries. Hubble's expansion law eventually led to the discovery of dark energy in the late 1990s. Scientists measuring the rate of expansion expected it to slow down due to gravity, but instead they found it was accelerating. Something unknown, a mysterious force, is driving galaxies apart faster and faster. Without Hubble's original discovery, we wouldn't even know to ask the question. Today, the Hubble constant is still debated. Different methods of measuring cosmic expansion, using supernovae, galaxy surveys, or the cosmic microwave background, give slightly different results. This tension, known as the Hubble tension, is one of the biggest unsolved problems in cosmology. Is it a flaw in our measurements, or a hint at new physics beyond our current theories? Either way, Edwin Hubble's name lives on at the center of this cosmic puzzle. So when we say what Edwin Hubble saw changed everything we know about the universe, it isn't just history, it's a living truth. His discoveries ripple through every branch of astronomy, from the study of galaxies and black holes to the hunt for exoplanets and the mystery of dark energy. And as we push deeper into the cosmos with next-generation observatories like the James Webb Space Telescope, we're continuing the work Hubble began, looking further, questioning more deeply, and uncovering truths that will shape our future understanding of reality. If you're fascinated by these profound discoveries, make sure you're subscribed to Starsky Science. We're just scratching the surface of the universe's most mind-bending mysteries, and the story of Edwin Hubble is the foundation of it all. For a long time, astronomy was filled with quiet assumptions. Scientists, philosophers, even poets, all worked under the belief that the cosmos was small, local, and contained. But once Hubble demonstrated that the universe stretched far beyond our own galaxy, the silence gave way to awe. Suddenly, we were forced to confront a universe that was alive, restless, and constantly in motion. The expanding universe wasn't just a concept, it was a revolution in thought. And like all revolutions, it raised questions that shook the very foundation of science. One of the earliest questions was straightforward, yet deeply unsettling. If the universe is expanding, then what is it expanding into? This question puzzled even the most brilliant physicists. Space itself, Hubble showed, was stretching like dots drawn on the surface of an inflating balloon. To imagine that reality itself could be elastic was almost too much to take in. It wasn't just that galaxies were moving away from us, it was that space itself was carrying them apart. And this brought forward another stunning realization. If the universe is expanding today, then it must have been smaller in the past. Trace it back far enough, and it all converges to one unimaginable moment of origin. This was the seed that would later grow into the theory we now call the Big Bang. Although Hubble himself never used that term, his observations lit the fuse of one of the most profound scientific ideas in history, the idea that the universe had a beginning. But let's pause here. Think about this for a moment. For centuries, people had looked up at the stars and assumed eternity. They thought the universe had always existed, unchanged and infinite. Suddenly, here was evidence suggesting that everything, every star, every galaxy, even time itself, had a starting point. Can you imagine the shock of realizing that the cosmos itself had a birthday? This wasn't just science. This was philosophy, spirituality, and imagination colliding all at once. Astronomers, theologians, and thinkers began debating endlessly. If the universe had a beginning, what caused it? Was it an act of physics or something beyond? The mystery only deepened as more data flowed in. NASA scientists often refer to Hubble's findings as the turning point of modern cosmology. It's because once you admit the universe is expanding, you're opening the door to a whole chain of discoveries. For example, if galaxies are racing away from us, then the light they emit stretches as it travels. That's why we see galaxies tinted red in their spectra, a phenomenon called redshift. This was the critical clue Hubble used to measure distances and velocities, building the first cosmic map of motion. His work laid the foundation for what would later be called the cosmic distance ladder, a set of techniques astronomers used to measure distances across unimaginable scales. From Cepheid variable stars to Type Ia supernovae, each rung on this ladder gave humanity a new way to peer deeper into the cosmos. And each rung confirmed the same thing. The universe is vast, dynamic, and growing. But with each discovery, the questions only grew. If the universe is expanding, will it expand forever? Or will gravity one day pull everything back into a collapse, a big crunch? Some scientists argue the universe may continue to expand endlessly, cooling into a cold, dark, lifeless void. Others speculate that mysterious dark energy, which accelerates expansion, might tear space itself apart in what's called the Big Rip. Imagine galaxies shredding, stars dissolving, atoms ripped from within. That's the scale of the questions Hubble's telescope raised. And here's where I want to bring you in. If you had to choose, would you rather the universe end in a big crunch, collapsing back into a fiery origin, or in a big freeze slowly fading into silence? Let me know your answer in the comments below, because I'm curious how you see the fate of everything we know. While you think about that, let's continue tracing the impact of Hubble's work. Beyond the questions of beginnings and endings, his discovery forced scientists to completely rewrite the scale of human existence. We were no longer inhabitants of a single galaxy, but members of an ocean filled with billions upon billions of galaxies. The scale is so overwhelming that even today, with powerful telescopes, we've only glimpsed a fraction of the total. Every patch of sky, no matter how empty it seems, reveals countless galaxies when magnified. Hubble himself once remarked that these galaxies were like island universes. Each one, a home for billions of stars, with untold worlds possibly circling them. Suddenly, the question of life beyond Earth became not just possible, but statistically probable. With so many galaxies, so many stars, and so many planets, how could we be alone? His discovery wasn't just about physics, it was about our place in the cosmos. Over the decades, scientists built on Hubble's foundation. The Hubble Space Telescope, named in his honor, gave us breathtaking images of galaxies colliding, stars being born, and nebulae glowing in brilliant colors. These images didn't just confirm his ideas, they inspired generations to look up and wonder. They're reminders that the cosmos isn't just out there. It's alive, evolving, and deeply connected to us. But perhaps the most profound legacy of Hubble's discovery is this: knowledge doesn't shrink the human spirit, it expands it. With every galaxy discovered, we find ourselves smaller, yes, but also part of something far greater. His work showed us that humility and wonder can exist side by side, and that science isn't about removing mystery, it's about deepening it. So when we talk about Edwin Hubble, we're not just talking about an astronomer with a telescope. We're talking about a man who held up a mirror to the universe and showed humanity a reflection it had never seen before. One that was infinite, restless, and forever expanding. And this, my friends, is why his discovery still matters today. It's not just about galaxies moving away. It's about us moving forward. It's about curiosity, exploration, and the courage to accept that the universe is bigger, stranger, and more beautiful than we ever imagined. When Edwin Hubble proved the universe was expanding, the ripple effect reached far beyond astronomy. His work touched physics, philosophy, and even the way humanity thought about time itself. But one of the most dramatic consequences of his discovery was its connection to Albert Einstein's theory of relativity. Einstein's equations, written in 1915, suggested that space and time were not rigid and fixed, but flexible, capable of bending and stretching. But Einstein himself was uneasy with the idea of an expanding universe. In fact, he inserted something called the cosmological constant into his equations, essentially a mathematical trick, to force the universe to stay static. He didn't like the thought of cosmic instability. The universe, in his mind, should be eternal and unchanging. But when Hubble showed the galaxies were flying apart, Einstein was stunned. He later admitted that his cosmological constant was the biggest blunder of his career. Ironically, decades later, scientists rediscovered that some form of cosmological constant, what we now call dark energy, does seem to exist. It's the mysterious force driving the acceleration of the universe's expansion. So what Einstein once considered a mistake may have been closer to the truth than anyone realized. This is one of the most fascinating twists in science. Discoveries often circle back, forcing us to rethink what we thought was wrong. Hubble's data didn't just prove Einstein wrong, it revealed something even stranger. Space wasn't just expanding, the rate of expansion itself could change over time, driven by forces we still don't fully understand. To grasp the scale of what Hubble revealed, think about this. The universe is not just galaxies drifting apart like boats on an ocean. The ocean itself is growing. Imagine drawing dots on a balloon and blowing it up. The dots move away from one another, not because they're moving on their own, but because the surface itself is stretching. That's what our universe is doing. Space itself is growing. This simple observation became the seed of one of the most powerful ideas in modern science, the Big Bang Theory. The logic is simple but profound. If everything is moving apart today, then in the past, everything must have been closer together. Trace it far enough back, and all of reality was once compressed into an incredibly hot, dense state. A single moment of creation, not just of matter and energy but of space and time itself. The Big Bang wasn't an explosion in space, it was the expansion of space. This idea was shocking to scientists at first. Even Hubble himself hesitated to draw conclusions about cosmic origins. But his data left the door open for others, like Georges Lemaitre, a Belgian priest and physicist, who proposed that the universe had indeed started from a primeval atom. Decades later, in 1965, the Big Bang Theory gained overwhelming evidence. Two radio astronomers, Arno Penzias and Robert Wilson, accidentally discovered a faint microwave signal coming from every direction in space. This was the leftover radiation from the hot, early universe, the cosmic microwave background. Without Hubble's initial discovery of an expanding universe, no one would have known how to interpret that signal. Suddenly, the Big Bang wasn't just theory. It was reality. NASA scientists often say that Hubble opened the first door into the real history of the cosmos. From him, we learned that the universe isn't static but evolving. From the Big Bang, we learned that it had a beginning. And from later discoveries, we now know it has a future. But what kind of future? That question remains one of the greatest mysteries of cosmology. Will the universe expand forever? Will dark energy eventually rip space apart? Or could new physics, unknown to us today, reverse the expansion someday? It's almost poetic that the same discovery which gave us our first glimpse of the universe's birth also forces us to confront its death. That's the power of science. It gives us answers, but also bigger, more profound questions. And here's where I want to pause and speak directly to you. If you're enjoying this dive into the discoveries of Edwin Hubble and the mysteries of the universe, make sure to like this video right now. It really helps more people find Starsky science, and it tells me you'd like to see more documentaries like this. And of course, don't forget to subscribe if you haven't already, so you don't miss the next episode where we'll keep exploring the universe together. Now back to the story. After Hubble, the role of astronomers changed forever. No longer were they just stargazers charting positions. They became cosmic archaeologists, unraveling the history of time itself. Hubble's redshift data became the key to measuring the age of the universe. For decades, scientists debated the exact number, with early estimates ranging wildly from 2 billion to 20 billion years. Today, thanks to Hubble's legacy and modern observatories like Planck, we know the universe is about 13.8 billion years old. And yet, this number carries with it staggering implications. If the universe has been expanding for 13.8 billion years, then the light we see from the most distant galaxies has traveled across space for almost the entire age of everything. Looking through a telescope is quite literally looking back in time. Every photon captured is a message from the past, a silent witness to the universe's history. The Hubble Space Telescope, launched in 1990, carried on this mission beautifully. When it captured the famous Hubble Deep Field, focusing on what seemed like an empty patch of sky, the results shocked the world. Instead of darkness, the image revealed thousands of galaxies, each one brimming with billions of stars. A tiny window in space turned out to be a treasure chest of universes. Think about what that means. Every direction we look, the universe is overflowing with galaxies. Our Milky Way is not just one among many, it's one among trillions. And each of those galaxies could hold countless planets, perhaps even civilizations wondering the same things we do. Hubble's discovery was not just about science, it was about humility. It forced us to accept that our world, our solar system, our galaxy, are tiny parts of an endless cosmic ocean. And yet, far from making us insignificant, it gives us a role in something grander. We are participants in the universe's story, capable of looking out, measuring, questioning, and seeking meaning. And that is the ultimate power of Edwin Hubble's vision. Not just that he discovered galaxies beyond our own, but that he reminded humanity to keep looking, to keep asking, and to never stop being curious about what lies beyond. Edwin Hubble's work didn't just open the universe, it also left us with one of the most stubborn puzzles in modern science: the precise rate of cosmic expansion. This rate, known as the Hubble constant, is one of the most important numbers in cosmology. It defines how fast galaxies are moving away from each other, and therefore tells us the size and age of the universe. Hubble himself estimated the constant in 1929, but his values were far from accurate. He overestimated the distances to galaxies, which led him to calculate an expansion rate that was far too high. For a time, it seemed as if the universe was only about 2 billion years old, an age that directly clashed with the known ages of stars on Earth. Something was clearly off. Decades of refinement followed. Astronomers used better distance indicators, improved measurements of Cepheid variables, and eventually Type Ia supernovae, stellar explosions that shine with nearly uniform brightness across the cosmos. These became standard candles, allowing astronomers to calculate distances with greater precision. But even with advanced methods, a strange problem emerged. Two different techniques gave two different answers. When scientists measured expansion using nearby galaxies and Cepheids, they got one value. When they measured using the cosmic microwave background from the early universe, observed by satellites like Planck, they got another. Both values were precise, both confirmed by independent studies, but they didn't agree. This conflict is called the Hubble tension, and it's one of the great mysteries of modern astronomy. Are we missing something fundamental about the universe? Could new physics be required to explain why these numbers don't match? Some scientists suggest dark energy may behave differently than we expect. Others propose exotic particles, or that gravity itself may need to be revised on cosmic scales. Whatever the explanation, it shows that Hubble's original discovery is still alive, still unfolding, still challenging us. And this leads naturally to another profound mystery: the invisible scaffolding of the cosmos, dark matter and dark energy. Dark matter was hinted at long after Hubble, when astronomers noticed that galaxies were spinning faster than their visible matter could account for. Something unseen was adding gravitational pull, binding galaxies together. That something was dark matter, and it makes up about 27% of the universe. It doesn't emit light, doesn't reflect light, doesn't interact with electromagnetic waves at all. It's invisible, detectable only by its gravitational fingerprint. Dark energy, on the other hand, was discovered in the late 1990s, when astronomers studying distant supernovae realized that the universe wasn't just expanding, it was accelerating. Instead of slowing down under gravity's pull, galaxies were being pushed apart faster and faster. This implied the existence of a mysterious repulsive force permeating space itself. Dark energy is estimated to make up nearly 70% of the universe. That leaves less than 5% for everything we see: stars, planets, gas, dust, even us. Imagine that. Everything humanity has ever observed, built, or lived through is only a sliver of reality. Hubble's discovery was the first step toward this shocking realization, that most of the cosmos is hidden from view, governed by forces and matter we still don't understand. This changes how we think about the universe. It's not a finished book, but a draft still being written. Hubble gave us the first chapter, but the plot is far from over. Every new observation opens a deeper mystery. The Hubble tension, dark matter, dark energy, these aren't minor footnotes. They're clues to something bigger, something revolutionary. Some scientists believe we are on the verge of a new paradigm shift, as profound as Hubble's in 1929. If we solve these puzzles, we may uncover laws of physics that go beyond Einstein, beyond the standard model, beyond anything we know. And this is why astronomers today still look back to Edwin Hubble. He taught us that the universe is not static, not simple, and not small. He showed us that our assumptions can be shattered with a single well-measured observation. His legacy is a reminder: when we think we know the cosmos surprises us. Consider this. In just a century, we've gone from thinking the Milky Way was the entire universe to realizing that we're in one galaxy among trillions, in a universe dominated by invisible forces. What will the next century reveal? Perhaps we'll discover that dark matter is made of exotic particles, or that dark energy points to new dimensions of reality. Perhaps we'll even find that the universe is part of something larger, what some scientists cautiously call the multiverse. All of it began with Edwin Hubble standing at a telescope, watching tiny smudges of light and daring to measure them. His careful work transformed those smudges into galaxies, and those galaxies into the building blocks of cosmic truth. In the end, what Hubble saw didn't just change astronomy, it changed what it means to be human. It placed us in a universe far bigger than we imagined, and it reminded us that discovery is endless. The more we learn, the more mysteries open before us. When the Hubble Space Telescope was launched in 1990, it was more than just a tribute to Edwin Hubble's legacy. It was a new set of eyes for humanity, eyes placed above the blur of Earth's atmosphere, capable of seeing the universe in a clarity no ground-based telescope had ever achieved. First, though, the mission seemed doomed. Early images came back blurry, and the scientific world was shocked. After years of anticipation, it looked like Hubble was a billion-dollar disappointment. The cause was traced to a tiny flaw in the telescope's main mirror, an error of just 2 microns, thinner than a human hair, but enough to distort the view of the cosmos. In 1993, NASA astronauts performed one of the most daring repair missions in space history. They installed corrective optics, essentially giving Hubble a pair of glasses. From that moment on, Hubble delivered images that changed astronomy forever. One of its most astonishing contributions was proof that black holes exist at the centers of galaxies. By tracking the motion of stars and gas swirling at incredible speeds near galactic cores, Hubble showed that only a supermassive black hole could account for such gravity. Suddenly, the idea of monstrous objects millions or billions of times the mass of the Sun lurking in every galaxy became scientific reality. Our own Milky Way's center, once mysterious, is now known to host a black hole named Sagittarius A star. But Hubble didn't stop there. It revealed the life cycles of stars in extraordinary detail. Images of the Eagle Nebula's pillars of creation became cultural icons, showing vast towers of gas and dust where new stars were being born. For the first time, the process of stellar creation wasn't just theoretical. It was visible, breathtaking, and undeniable. Hubble also gave us a front-row seat to cosmic violence. It captured galaxies colliding, spiraling into one another in slow-motion dances that span billions of years. These weren't rare accidents but fundamental parts of galactic evolution. Even our Milky Way is on course to collide with the Andromeda galaxy in about 4 billion years. Hubble's images showed us what that future might look like. Two great spirals merging into a new cosmic city of stars. Perhaps its most revolutionary achievement, however, came from looking not at the grand structures of the nearby universe, but at what seemed to be emptiness. In 1995, astronomers pointed Hubble at a tiny dark patch of sky near the Big Dipper and let it stare for 10 days. The result became the Hubble Deep Field, an image that revealed thousands of galaxies, each one a universe of stars, packed into a space smaller than a grain of sand held at arm's length. That image was more than beautiful. It was transformative. It showed that the universe is not only vast, but filled to bursting with galaxies in every direction. Later versions like the Hubble Ultra Deep Field looked even further back in time, capturing galaxies as they were billions of years ago, shortly after the Big Bang. Each pixel became a history book, each faint smudge a relic from the dawn of time. Hubble's contributions didn't stop at distant galaxies. It also turned its gaze to planets within our own solar system, photographing storms on Jupiter, auroras on Saturn, and even the icy fragments of comet Shoemaker-Levy 9 slamming into Jupiter's atmosphere. It became not just a telescope for deep space, but a guardian eye watching the dynamic changes of our cosmic neighborhood. And as technology advanced, Hubble began helping in a new field of astronomy, the study of exoplanets. By observing the way starlight dimmed as planets passed in front of their stars, Hubble was able to analyze the atmospheres of distant worlds. For the first time, humanity could detect water vapor, methane, and other molecules in alien skies. It wasn't just galaxies Hubble revealed. It was the possibility of other Earths. All of this ties back to Edwin Hubble's first simple discovery, that the universe is expanding, alive, and full of worlds beyond imagination. His work cracked open the door, but the telescope that bears his name swung it wide, letting us see wonders we never dreamed of. Yet, even as Hubble answered questions, it sparked new ones. The telescope confirmed that dark energy is real, shaping the fate of the cosmos. It mapped the distribution of dark matter through gravitational lensing, revealing invisible webs binding galaxies together. And it deepened the mystery of the Hubble constant, showing the expansion rate of the universe with exquisite precision, only to make the discrepancy with early universe measurements more puzzling. This is the paradox of discovery. The more clearly we see how much we don't understand. Hubble the man gave us galaxies. Hubble the telescope gave us the universe in stunning detail. But both left us with mysteries that may define science for generations. As we look at these images, the colliding galaxies, the glowing nebulae, the infant galaxies from the dawn of time, we can't help but feel the echo of Edwin Hubble's own moment of revelation. He once stood at a telescope and realized the universe was larger than anyone dared imagine. Today, thanks to the space telescope named after him, we stand at the same threshold again. The story of Hubble is not just about looking outward. It's about looking inward, realizing that every discovery reshapes who we are and how we understand our place in the cosmos. And that's why his legacy is more alive today than ever before. For centuries, humans had wondered whether the laws of physics we observed on Earth were the same laws that govern the stars. Could the forces shaping our planet also be at work across the unimaginable vastness of the cosmos? Edwin Hubble's discoveries offered a profound answer. Yes. What he observed through the telescope wasn't just distant galaxies. It was a confirmation that the same rules of motion, energy, and gravity were universal. His work revealed a cosmic order far beyond what anyone had dared to believe. But let's pause for a moment. Imagine the courage it took to say to the scientific world, "Our galaxy isn't the whole universe." That was a bold and controversial statement. Yet, through his persistence, Hubble reshaped science into what we now call modern cosmology. And in doing so, he inspired generations of scientists, from Albert Einstein to the astronomers at NASA who today continue pushing the boundaries of what we know. Hubble's most famous achievement, of course, was proving that the universe is expanding. But let's go deeper into what that really means. If galaxies are moving away from us, then at some point in the past, they must have been much closer together. This is where the seeds of the Big Bang theory began to take shape. Hubble didn't just show us galaxies. He showed us that the universe itself had a beginning. And that single idea has transformed physics, astronomy, and even philosophy. When we talk about the Big Bang, people often imagine a massive explosion in the middle of space. But that's not quite accurate. The universe didn't explode into empty space. It was space itself that expanded. Every galaxy, every star, every planet, and even the atoms in your body all came from that first expansion. And without Hubble's observations, we might still be blind to this truth. Now let's add another layer to the story. The mystery of dark matter. As astronomers studied the movement of galaxies, they noticed something strange. The stars at the edges of galaxies were moving far too quickly. According to the rules of gravity, they should have been flung out into the darkness. But they weren't. Something invisible was holding them together. This hidden force was later called dark matter. Without Hubble's groundwork in mapping galaxies, we might never have realized this invisible skeleton of the universe even existed. And then came the even greater enigma: dark energy. In the late 1990s, two teams of astronomers studying distant supernovae made a shocking discovery. Not only was the universe expanding, it was accelerating. Something, an unknown force, was pushing galaxies apart faster and faster. We call it dark energy, and it makes up nearly 70% of the universe. Yet we have no idea what it really is. Hubble's early work on expansion was the stepping stone that led scientists to uncover this mysterious and dominant force. So, in many ways, Edwin Hubble is not just a name in astronomy, he is the foundation of modern cosmology. Without him, we wouldn't know about the expansion of space, the birth of galaxies, or even the true scale of the cosmos. He gave humanity a gift: the realization that we are part of something infinitely larger than ourselves. But I want to ask you something. If you could look through Hubble's telescope and see what he saw for the very first time, what do you think your reaction would be? Awe? Fear? Excitement? Tell me in the comments. I'd love to know how you imagine that moment would feel. Before we move forward, let me quickly remind you. If you're enjoying this deep dive into Edwin Hubble's discoveries and the incredible story of the expanding universe, please take a second to like this video and subscribe to Starsky Science. It really helps the channel grow and ensures you won't miss our upcoming explorations into the biggest mysteries of space. Now let's go even deeper. The Hubble Space Telescope, named in Edwin Hubble's honor, has been orbiting Earth since 1990. This instrument has become one of the most important tools in human history for observing the universe. Thanks to it, we've seen the birthplaces of stars inside vast nebulae, galaxies colliding in spectacular dances, and light that has traveled billions of years to reach us. In a sense, the Hubble Space Telescope allowed us to continue what Edwin Hubble himself started: the quest to see the universe as it truly is. But even the Hubble Space Telescope has its limits. To look even further back in time, we now use the James Webb Space Telescope. Webb is allowing us to see galaxies as they appeared only a few 100 million years after the Big Bang. These images are rewriting everything we thought we knew about the early universe. Once again, we return to the question: what would Edwin Hubble think if he saw this today? Would he be surprised? Or would he smile, knowing that his work was the spark that made all of this possible? Scientists often say that astronomy is a way of looking backward in time. Because light travels at a finite speed, the further we look into space, the further we look into the past. Edwin Hubble's telescope opened a window not just to distant galaxies, but to the history of the cosmos itself. Each galaxy he measured was like a time capsule, carrying information across billions of years of travel through space. And here's the astonishing part. Everything you see in the night sky is history. When you look at the stars, you're not seeing them as they are right now, you're seeing them as they were years, centuries, or even millennia ago. Hubble's genius was in realizing that those tiny points of light could tell us the grandest story ever told: the story of the universe. The legacy of Edwin Hubble isn't just written in textbooks, it's written in the sky itself. Every time scientists plot the expansion of the cosmos, every time they measure the distance to a galaxy, they're walking in the footsteps of Hubble. And every discovery we make today, whether it's dark matter, dark energy, or the earliest galaxies, traces its roots back to that moment in 1924, when Hubble looked through a telescope and realized the universe was so much bigger than anyone had imagined. When Edwin Hubble presented his evidence that the universe was expanding, it didn't just shake the world of astronomy, it shook Albert Einstein himself. Before Hubble's work, Einstein had introduced something he called the cosmological constant into his equations of general relativity. Why? because his math suggested the universe should be either expanding or contracting, but he believed the universe was static and eternal. To fix this, he added the constant to keep the cosmos balanced and motionless. But once Hubble's data became undeniable, Einstein admitted his so-called fix was unnecessary. He even called it the biggest blunder of his life. Hubble's observations forced the greatest physicist of the age to re-examine his own theories. And that's the power of science. Evidence, not ego, defines truth. This moment is a perfect example of how one discovery can ripple across multiple fields. Hubble's revelation didn't just redefine astronomy, it redefined physics itself. Suddenly, Einstein's general relativity wasn't describing a static cosmos, it was describing a living, expanding one. But what does this mean beyond science? Think about the philosophical impact. For thousands of years, people believed the universe was eternal, without beginning or end. The idea that time and space themselves had a starting point was both exhilarating and terrifying. It meant that the universe hadn't always existed, it was born. And here lies one of the most fascinating crossroads between science and philosophy. If the universe had a beginning, what came before? Was there a before? Or does the concept of before collapse when space and time themselves only came into existence with the Big Bang? These are the kinds of questions Hubble's work indirectly raised, questions that philosophers and scientists still wrestle with today. Religious thinkers also took notice. Some saw the Big Bang as scientific confirmation that the universe was created, aligning with long-held beliefs in a divine beginning. Others saw it as a purely natural process, requiring no outside influence. Either way, Hubble's discovery forced humanity to confront questions far larger than astronomy. It forced us to reconsider the very nature of existence. Now let's look at how this influenced modern science. The Big Bang model became the foundation for nearly every branch of cosmology. The age of the universe could now be estimated by measuring its expansion rate. Today, that estimate is about 13.8 billion years. Hubble gave us not just galaxies, he gave us the timeline of the cosmos itself. But here's where things get tricky. Scientists today still debate the exact rate of the universe's expansion, known as the Hubble constant. Yes, it's named after Edwin Hubble, but modern measurements don't always agree. Observations from the cosmic microwave background, the faint afterglow of the Big Bang, suggest one number. Observations of nearby galaxies and supernovae suggest another. This disagreement is one of the greatest mysteries in modern physics. It could mean our understanding of the universe is incomplete, or that some entirely new physics is waiting to be discovered. Think about how incredible that is. Nearly a century after Hubble first spotted galaxies beyond the Milky Way, his name is still at the center of cutting-edge debates about the universe. His discovery didn't just end a chapter of science, it began one that continues to this day. And the story doesn't stop with physics. Hubble's expansion of the universe gave rise to another concept, the idea of a multiverse. If our universe had a beginning, could there be other universes born under different conditions? Could there be countless universes, each with its own rules existing parallel to ours? These ideas are still highly theoretical, but they trace their roots back to Hubble's revelation that our universe is not static, not eternal, but dynamic and evolving. Here's something to reflect on. Without Hubble's work, we might never have asked these questions. The possibility of alternate universes, the search for dark energy, the attempt to unify physics, all of it is downstream of that night when Edwin Hubble pointed his telescope at the Andromeda galaxy and realized it wasn't just a nebula, but a whole other galaxy millions of light-years away. But let's not forget the human side of this story. Hubble himself was known for being both brilliant and proud. Some say he had a flair for dramatics, even insisting on being called Dr. Hubble, despite technically not holding a PhD in astronomy. Yet beneath the pride was a man driven by pure curiosity. He wanted to know the truth about the universe, no matter how shocking it might be. And maybe that's the greatest legacy Hubble left us. Not just facts about galaxies and expansion, but a spirit of curiosity that fuels science itself. He taught us that the universe is stranger, larger, and more mysterious than we could ever imagine. And with each discovery, new questions arise, pulling us deeper into the unknown. Think about it, before Hubble, we thought we lived in a quiet little galaxy, drifting alone in the cosmos. After Hubble, we realized we are part of a universe filled with billions of galaxies, each with billions of stars, each possibly with planets like ours. His discovery didn't just expand the universe. It expanded the possibilities for life, for exploration, and for our own place in the cosmic story. And that's why his name will forever be etched into history. Hubble showed us that the universe is not what it seems, that reality is bigger than our imagination. And he left us with one of the most important truths in all of science. The universe is not static. It is alive, growing, and forever changing. When Edwin Hubble looked through the Hooker telescope in the 1920s, he never could have imagined that nearly a century later, a spacecraft orbiting far above Earth would bear his name and carry his vision to unimaginable distances. The Hubble Space Telescope, launched in 1990, has become one of the most important scientific instruments in human history. And it's no exaggeration to say that it has changed everything we know about the universe, just as Edwin Hubble once did. At first, though, Hubble's namesake telescope had a rocky start. Shortly after launch, scientists realized its main mirror had been polished to the wrong shape. The telescope's images were blurry, and critics quickly labeled it a disaster. But engineers and astronauts didn't give up. In 1993, during a daring space shuttle mission, astronauts installed corrective optics, essentially glasses for the telescope. Overnight, Hubble went from embarrassment to triumph, transforming into the eye of humanity in space. And what an eye it has been! Through Hubble, we've seen the birthplaces of stars inside massive clouds of gas and dust. We've witnessed galaxies colliding in slow-motion dances that take billions of years. We've observed black holes at the centers of galaxies, bending light and swallowing matter. And perhaps most breathtaking of all, we've seen galaxies so far away that their light began its journey not long after the Big Bang itself. One of Hubble's most iconic contributions was the Hubble Deep Field. In 1995, astronomers pointed the telescope at what looked like an empty patch of sky, an area no bigger than a grain of sand held at arm's length. For 10 days, Hubble collected light from this nothingness. The result stunned the world. The image revealed thousands of galaxies, each containing billions of stars, hiding in what appeared to be empty space. The message was clear. The universe is far richer, far more crowded, and far more astonishing than we ever imagined. That single image changed astronomy. It showed us that no matter where you look in the sky, the universe is overflowing with galaxies. And it confirmed something Hubble himself had suspected. Our universe is unimaginably vast, with perhaps trillions of galaxies spread across the cosmos. But the Hubble Space Telescope didn't just confirm Hubble's vision, it extended it. Using Hubble, scientists discovered the accelerating expansion of the universe, leading to the idea of dark energy. They measured the atmospheres of distant exoplanets, searching for signs of habitability. They even refined the age of the universe, confirming that it is about 13.8 billion years old. It's poetic, isn't it? Edwin Hubble, who once looked through a ground-based telescope and glimpsed the vastness of space, gave his name to the telescope that carried his dream into orbit, and together, they gave humanity the ability to look back nearly to the dawn of time. But science never stands still. As Hubble aged, NASA and its partners built a successor, the James Webb Space Telescope. Launched in 2021, Webb is even more powerful, capable of seeing in infrared light and peering further back in time than Hubble ever could. Already, Webb has captured galaxies forming just a few 100 million years after the Big Bang. Structures so early and so developed that scientists are rethinking how quickly galaxies can form. And yet, every time Webb makes a discovery, it's worth remembering. None of this would have been possible without Edwin Hubble. His work is the foundation. Webb is showing us the universe's childhood, but Hubble was the one who first proved the universe was expanding at all. The Hubble and Webb telescopes are not just instruments, they are humanity's time machines. They allow us to see the universe as it was billions of years ago, revealing the story of creation itself. In a sense, they are continuing the work that Edwin Hubble started with his telescope on Mount Wilson nearly a century ago. But let's not forget the broader impact of this work. Hubble's discoveries didn't just advance science, they inspired entire generations. The images from the Hubble Space Telescope have become cultural icons, sparking wonder in millions of people who may never have read a physics paper or studied astronomy. These images remind us that science isn't just about equations. It's about awe, imagination, and the desire to know what lies beyond. And the story doesn't stop with space telescopes. The expanding universe is central to missions like the European Space Agency's Euclid Telescope and NASA's upcoming Nancy Grace Roman Space Telescope. Both will continue exploring dark matter and dark energy, building on the questions first raised by Hubble's observations. Each new mission is another thread in the tapestry of cosmic discovery, woven into a story that began with one man and a telescope. But let's pause here and consider something. Every time we launch a telescope, every time we point our instruments into the sky, we are asking the same question Hubble once asked: what is out there? And every time the universe responds with surprises. If Hubble could look through the telescopes of today, what would he say? Would he be astonished that his name lives on in one of the most famous instruments of all time? Would he be humbled that his discovery of galaxies led to entire space missions dedicated to unraveling the universe's mysteries? Or would he simply smile, knowing that curiosity never ends, that once you open the door to the cosmos, it never closes again? This is the essence of Hubble's legacy. Not just expanding our knowledge, but expanding our imagination. He showed us that the universe is not small, not simple, but vast, dynamic, and alive with possibilities. And every telescope, every discovery, every breakthrough since has been a continuation of that vision. So when we look at the Hubble Space Telescope's images, or marvel at the discoveries of the James Webb, we are really looking at Hubble's legacy stretching across time. A legacy built not just on facts but on wonder. And perhaps that's the greatest truth of all. Hubble didn't just change science. He changed the way humanity sees itself. Tiny, fragile, but connected to something infinite. Edwin Hubble's name is etched not only in the annals of science but in the very stars above us. What he saw through his telescope in the 1920s was more than just galaxies. It was the key to unlocking the universe itself. He proved that our Milky Way was not alone, that the cosmos was vast beyond imagination, and that space itself was stretching and growing. With that one revelation, he forever changed the way humanity understands reality. But Hubble's impact didn't end in his own lifetime. Every discovery since, the mapping of dark matter, the detection of dark energy, the study of black holes, the exploration of distant exoplanets, has its roots in his work. He handed us a universe that was alive and evolving, and he gave scientists the framework to ask deeper, harder questions. And those questions still haunt us today. What is dark energy? What is dark matter? How did galaxies form so quickly after the Big Bang? Is our universe just one of many? These mysteries stand as towering challenges, but they are also invitations, reminders that discovery never ends, and curiosity is our greatest tool. Hubble also changed something deeper, our perspective on life itself. Before his discoveries, humanity thought of itself as central, perhaps unique. But when we realized there were billions of galaxies, each with billions of stars, the question of life elsewhere became unavoidable. Somewhere out there, orbiting a distant sun, could be another planet with oceans, with skies, with intelligent beings staring up at their night sky, wondering the same things we do. And it all began with Edwin Hubble daring to look further. The legacy of Hubble's vision is alive today in every photograph sent back by the Hubble Space Telescope, in every breathtaking image captured by the James Webb, and in every new mission launched to probe the mysteries of space. These instruments are humanity's eyes, continuing the work of the man who first showed us that the universe is bigger than we ever dreamed. But perhaps the greatest gift Hubble left us isn't just knowledge, it's wonder. He reminded us that no matter how much we learn, there will always be something more, something deeper, something stranger waiting to be discovered. The universe is not just a place. It's a story, one that began billions of years ago and continues to unfold, with us as both participants and observers. And so when we look at the stars tonight, we're not just seeing distant suns. We're seeing the legacy of a man who lifted our eyes and expanded our vision. We're seeing the echoes of Edwin Hubble's discovery that shattered old beliefs and opened the door to a universe without end. He showed us that we are small, yes, but in our smallness lies greatness. For in the face of an infinite universe, we dare to ask, we dare to seek, and we dare to understand. So the next time you see the night sky, remember, it was Edwin Hubble who first revealed its true scale, its true beauty, and its true mystery. And the adventure of discovery he began is far from over. Thank you for watching this deep exploration into the life and legacy of Edwin Hubble here on Starsky Science. If you found this video fascinating, please don't forget to like the video, share it with others who love the mysteries of the universe, And subscribe to Starsky Science so you never miss our upcoming documentaries on the biggest questions of space and time. The universe is expanding. Our curiosity is expanding. And with every discovery, so too does our understanding of who we are and where we belong.